Hello everybody, this is Dr. A, and in this video we are going to be exploring an example of right triangle trigonometry. So let's go ahead and get started. So to get started, we're going to write given. And this is going to be our given information, so basically our problem statement itself. And in this problem, we are going to be asked to compute the sine, cosine, and tangent of the angle theta. Now, also in this given information, we're going to be given a right triangle. So here is our right triangle, and here's the right angle. And the right triangle that we're given is going to have a height of 3 feet and a length of 4 feet. And then the angle theta we're interested in is right here, okay? So let's go ahead and get started with our solution. So beneath that, we're going to write solution so we know when we're actually starting our work. So again, we want to compute the sine, cosine, and tangent of the angle theta. Now, the first thing you need to recognize is that, yes, this is a right triangle, and we have our height, our vertical height is 3 feet, and our horizontal length is 4 feet. The angle is theta, but what we don't directly have is the hypotenuse, okay? We don't have that directly, but that's okay. We can figure out our hypotenuse. So the first thing we're going to do is we're going to say first compute the hypotenuse r, okay? So our hypotenuse r is going to be this diagonal length right here. So how do we do that? Well, of course, we use the Pythagorean theorem. So the Pythagorean theorem says the hypotenuse is equal to the square root of the horizontal length squared plus the vertical length squared. So punching this through, and hope maybe you don't need to punch this through, we are going to say that this is equal to 4 feet squared plus 3 feet squared. Oh, put my parentheses in the wrong place. 3 feet squared, not cubed, squared. So when we evaluate this, we're going to take the square root of 16 feet squared plus 9 feet squared. Now, when you evaluate that one step at a time, you get the square root of 25 feet squared. Okay, now if you follow your operations, you know that this is going to be the square root of 25 and then times the square root of feet squared. So just showing each step, one step at a time, you get 5 feet. Okay, so for those of you who are quicker with math, I'm sorry if this was a little bit trivial for you, but for those of you who maybe were unsure of where the idea of a 3-4-5 triangle came from, well, this is it. You can see that this is a 3-4-5 triangle by the Pythagorean theorem. So now that we have the hypotenuse r, we're ready to actually compute what the problem told us to compute, which was the sine, cosine, and tangent of that angle theta. So let's do this one at a time, one piece at a time. We know that the sine of an angle theta in a right triangle specifically is equal to the opposite side divided by the right triangle's hypotenuse, okay? So what is the side that is opposite of this angle theta? Well, it's this side that's clear across the right triangle. That's the 3-foot length. So we're going to say that's 3 feet, and then divided by what? Well, the hypotenuse. This is the diagonal length here that we just computed as 5 feet. So this is 3 feet over 5 feet, and we just get the simple fraction 3/5. Okay? What about the cosine of angle theta? Well, if you remember, what's the definition of the cosine of angle theta? That's going to be equal to the adjacent side divided by the hypotenuse. So again, the word adjacent means that It's the side that is next to angle theta that is not the hypotenuse, okay? Because the hypotenuse is its own separate third side of the triangle. So what is the side that is next to angle theta but is not the hypotenuse? Well, that's this side right here that is 4 feet. So we're going to say that this is equal to 4 feet divided by the hypotenuse, which of course we calculated as 5 feet. So this is the fraction 4/5. And then lastly, we're being asked to compute the tangent of angle theta, which is defined as the opposite side divided by the adjacent side of the right triangle in question, referencing the angle that we're interested in. So looking back at angle theta, what is the side opposite of theta? Well, that's 3 feet. And what is the length of the side that is adjacent to theta? That's not the hypotenuse, of course. That's 4 feet. So we're going to write that this is 3 feet over 4 feet. And of course, the units of feet cancel and you're left with 3/4. Okay, so a thing to note here is if you're a mathematician or a science person or an engineering person, we love to keep track of the units of measurements in a problem. So something to note here is that we had units of feet in these measurements, and notice that when I calculated the hypotenuse r, I kept track of those units of feet, and I saw how it reduced and canceled with a square root to leave me 5 feet as my final hypotenuse length. And then I also kept track of my units when I was computing my sine, cosine, and tangent of those angles. And you notice that the feet cancel with the fraction operation, and that's why you don't have any units with these fractions that became our final answer. So all of these feet canceled with the numerator and the denominator aspect of the fact that you have feet in the numerator and the denominator. So they cancel each other out. And so you are left with a unitless value as your sine of theta, cosine of theta, and tangent of theta. So that's going to conclude this very simple example video of some right triangle trigonometry operations.